Hi, and welcome back to Trimble Forensics Tech Tip Tuesdays. I'm Chris, and today we're going to be combining a few different techniques in Trimble Forensics Reveal and CrashMath to produce a 3D animated vault of a vehicle that goes airborne over an interstate median crossover. This is what it's going to look like when we're done. Ready to get started? Let's go. So let's start with our scene and just doing a quick walkthrough. So I have my scene loaded up. This is a 3-lane interstate with paved shoulders on both sides. So we have 1, 2, 3 lanes, paved shoulders on both sides, a median here, as well as a median crossover in the middle, and then another grass median on the other side. Now, we knew that the laser scan was going to pick up our roadway and the topography of our ditches and the topography of our median. However, what we knew it wouldn't get was the tire marks, the very faint tire marks that were in here. They were not braking marks. It was just a roll all the way up to the crossover, and then the subject went airborne over the crossover, landed here, and continued back up on the roadway. So we knew our laser scan wasn't going to pick up the tire marks in the grass just because of the nature of the grass and what time of year we dealt with this. It was not something that a laser scan was going to pick up. So we brought out our total station and just used the prism to shoot our points in here. So we have our point cloud and we have our points. Now we need to surface our median because the vehicle going up and airborne over is something that we're going to want to capture. So let's get to work on our median surfacing. Now, what I've done here is I've already drawn in my roadway. So I'm going to turn on my surfacing from my roadway and my road lines. I'll turn my cloud off just to show what we have. And there we have our tire marks. We hit our crossover. We go airborne. We come down here, and then we continue up on the road after that. So this is the area we want to work on. And again, I've already done the surfacing for the road lines. I've already got my crossover surfaced, and we're ready to go. So I'm going to turn on my construction lines layer, and here you can see all of my construction lines. These are lines that I only use for building my surfaces. Once I'm done building my surfaces, I turn my construction lines off, and I have a nice surface here that doesn't have anything else on it. So we're ready to go. I'll turn my construction lines on, and I'll just click on this construction line, and it might help if I lock my surfaces layer. Now, this is another thing that if you have problems like me where you want to select the line, but you inadvertently select the surface, if you lock your surfaces layer, so I put all of my median surfaces in one layer, all of my roadway surfaces in another, this allows me to lock my surfaces so I can't select them. This allows me to select my line and my line only. Now, the key is on this, instead of creating a construction line that went down and around the curve, I created a construction line that went through. However, I created anchor points right here and here. Same thing on the other side. I created a construction line that went through the crossover and only had a vertex where it connected up to the main road. Now on this, it's critical not to have a whole bunch of points, to just click in here and click, 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 and have a whole bunch of things in there. Simplicity is key when you're doing this. A lot like in the intersection tutorial that I did a few weeks back, where we surfaced a four-way intersection with the virtual total station. Simplicity is key when you're surfacing complex geometry like this. So what we're going to do now is we're going to create some construction lines for a median. Now we already have a curve here. However, if I could use a line and go from here to here, the surface isn't going to work. Remember, it's 2-line surfacing. The surfaces have to be apart from one another. So I'm going to make my construction layer active, and I'm going to go to my Draw tab. I'm going to grab a combo line. And what I'm going to do here is I'm going to do a line snap. I'm just going to snap to our line here. And again, I'm staying away from my corner here. I don't want to get the corner. I want to stay off of it. So I'm going to click here. Now I'm going to turn my point cloud on. I'm going to select a cloud point. I'm just going to hold my C key down just so it makes a nice curve. And I'm going to continue up to here. I'm going to turn my point cloud off just so I can see what I'm working with. Now I'm going to snap to my line right here. And when I'm done, I'll hit the escape key. And now when I jump down into 3D view, we now have the profile of the median here. So now when I make my median surfaces layer active, I'm going to select this line and this line. And in my actions, I'm going to create a surface. And since these two need to be reversed in my actions, I'm going to reverse the series. And there we go. I've got my grass. So I'm going to just change my texture here to grass 3. And there we have my 3-dimensional texture. Okay, so what I'm going to do is I'm going to repeat that process down the side here. And then I'm going to jump over to the other side and do the same thing. And there we go. So we have our median now that is completely surfaced, and we have our total station points here that are set to go, and we have them landing over here. Now what I'm going to do is I'm going to turn off my construction layer. And just like that, all the black lines are gone, and we have our tire marks. Now, what I did is I already drew in our tire marks just to save time, so I'll turn those on. And what I need to do is I need to conform those to our surface. So I'll select each one of my tire marks, and in my actions, I'm going to conform to terrain. And there we go. So we have our tire marks all lined up, and we are set to go. So what I'm going to do now is I'm going to lock my tire marks. I'm going to lock my surfaces just to make sure that they don't get edited or changed in any way. I'm going to lock my road lines. I'm going to lock my construction layer. I'm going to lock my cloud. I'm just going to lock everything that isn't important. And I'm going to turn off my total station measurements because I'm not really needing those at this point. All right, so now we're set to put our vehicle on our canvas. I'll go to top-down view, and this is just easier for me to do in top-down. I'm going to go grab a model. And this will go in the vehicle layer. And this was a Dodge Charger. There we go. So we're going to grab a 2015 Dodge Charger. I'm going to turn on my terrain snap just so that I put it on the terrain. And I'll put it on my canvas. From here, what I'm going to do is just rotate it around and align it on my tire marks. Now, one thing you can do to really align vehicles on the tire marks very accurately, especially if you've got a sideways slide or anything like that, you can use this wireframe button here over on the left. And this allows you to see, this one's a little difficult because our tire marks are in white, but allows you to see the tire and see the mark underneath, which allows you to position it just a little bit easier. When I'm done, I just turn my wireframe off and we're set to go. Now what I'm going to do is I'm going to take my vehicle And I'm going to move over to my shadow cars layer. I'm going to take my car and I'm going to copy it. I'm going to come over here to where the vehicle goes airborne, and I'm going to again make my shadow cars layer active, and I'm going to paste it. And since it positioned it below my terrain, in my actions, I'm just going to align to terrain and bring it up. Now from here, what I'm going to do is position my car where I need it to. And it looks good right about there. I'm just going to do another align to terrain, and that'll snap my car down where it needs to be. And I will give this a 50% opacity, just to make it somewhat transparent. So now I'll take that car and I will copy it. And I will paste it at the point of takeoff here. Next thing I'm going to do is place the same shadow car down at the end where it lands. And then I'll give one final car position where it comes up and out of the median. All right. And looks like we're where we need to be. Now, our shadow cars are just something for us to use as a guide, especially where we have the takeoff and landing. So now the next thing we need to do is we need to take some measurements of this angle. So we have the vault angle, and then we need to make a measurement of where the vehicle leaves the takeoff point and comes down. So what I'm going to do is go to my dimension layer. And in my tools, I'm going to grab my dimension tool. I'm going to snap to a point, which will be the center of the car. Now here we have a point-to-point distance of 25.42 feet. However, the distance that I'm really interested in is in parentheses behind. It shows an elevation change of 1.67 feet and a horizontal distance or level distance of 25.36. So it'll be 25.42 as the crow flies, but we have a rise of 1.67 and a run of 25.36. Now, the next dimension I'm going to do is from here, which is our takeoff point, where the center of the car is now being influenced by gravity. And I'm going to measure to this point over here, where the car lands. And again, the dimension that I'm looking for here is that the car fell 4.14 feet and traveled 165.53 feet across the ground. All right, we're in good shape. So now what we need to do is we need to figure out our takeoff distance. I'm sorry, our takeoff angle. So what I'm going to do is pull up my calculator. I'm going to bring it in here. And we have 1.67 by 25.36. And that gives us an approximate 6% incline, 6.4%. And we are good to go. So what I'm going to do is I'm going to open up CrashMath. And in our tools, you'll see here that we have an icon on the top called CrashMath. Go ahead and open that up. And CrashMath is an application that is included with your Trimble Forensics Reveal installation. So the license for CrashMath is the same license as you have for Trimble Forensics Reveals. So if your dongle is in and you're working with Reveal, or if you're using a network license, if you're working with Reveal, you can also work with CrashMath at the same time. So I'm bringing CrashMath up just to the side here. Okay, so with CrashMath open, what I'm going to do is I'm going to add or choose an equation. And this is where you can pick from your categories off to the left. And there is a lot of stuff in here. And odds are, if you can't find it in here, it probably doesn't exist. But I'm going to go to my airborne equation category, and I'm just going to scroll down here, and I want to find the takeoff velocity because I know my takeoff angle and my rise and my run for my fall. So we're going to come down here, and we're going to enter into velocity required to vault with a grade less than 6.8 degrees. And this one comes in just under that, so we'll be able to use it. All right, so we're going to add this equation. And I'm going to give it a name. And I'm going to call this speed at takeoff. So our distance, our horizontal feet, is 165.53 feet. Our grade from our calculator was 0.064. And our fall distance was negative 4.14. Now, when you've input enough variables, I'll make this just a little bit larger here. When you've input enough variables, you'll see the green checkbox here that says ready to solve, and we'll solve it. And it gives me a value of 172.927 feet per second. However, if I want the speed, it was change over to miles an hour, and that gives me a mile per hour value of 117.905, which was correct since we were pursuing this vehicle and it was traveling approximately 120 miles an hour. That does make sense. Okay, now that we have our takeoff, we've determined the speed at which the vehicle takes off from our point, and we do have it set. So what I'm going to do is I'm going to give this a case number. Case name. And this one happened on May 13th. For the parties. And we'll put our vehicles in, and you can put any comments that you want to. So this will just be for our case information. And when we print it out, it'll have all that information in it. Okay, one nice thing about CrashMath is that if you're wanting to give a range of values, you're not just stuck putting one value in, creating another equation, and running it again. You can create an increment. So if you wanted to change, say, the grade, if you wanted to give a range of grades, you could click on the increment checkbox, and you can give it a start and end value. So if you wanted to give it a start value of, say, 0.060, and you wanted to give it a high value of 0.070, and you wanted to do this in 9 steps, you would hit solve, and this would give you a range of values for a different slope. So if we had a takeoff angle or takeoff grade of 0.06, we could expect a speed of 120. If we had a takeoff slope of approximately 0.07, we're going to end up with 114 miles an hour for our takeoff velocity. So this does create a nice way for you to increment your values. If you do want to see a graph, you can do that, or you can copy the results to the clipboard for inclusion in your report. If you were using Microsoft Word or anything else to show what your values are in your report, you could very easily just copy it to the clipboard and paste it in. What we're going to do is we are going to take a look at what this looks like when we print it off. So when I click Print Preview, drag this back into this window. Here's our collision dynamics report, and here's our equation number 1, speed at takeoff. It gives our formula that we are using, our input values. It gives our results. And on page number 2, it gives us a graph and then works through the velocity calculation. But for this one, what we're going to do is we are going to close this, and we are not going to increment that value since I am pretty confident in my measurements. I believe that was a 0.064. And we could even take it out to a 0.0646 if we wanted to, just to really drill it down. We're still 117.509 miles an hour. Okay, so we have figured out now how fast the vehicle was going when it left the ground. Now what I want to do is I want to create an animation with this. So what I'm going to do is I'm going to take my car, and in my actions, I am going to add a motion path. Now this is where we have our motion path follow our terrain. So I'm going to turn on my terrain snap. I'm going to hold my C key, and I'm just going to trace a path along my tire marks until I get to about this point, in which case I'm going to change over to a point snap. I'm going to snap to this point to make sure that my vehicle is where my shadow car is. I'm going to snap to this point. And I'll snap to that point. And from here, we're back on the terrain. So we'll hold the C key. Move up to here. Now with our motion path created, what I'm going to do is hit escape, and we are set. So now when I click play, our vehicle travels along. However, we do have a bit of a problem here in that it's not following the correct trajectory. It's following a curve, but it's not the trajectory that we want it to follow. So what we need to do is we need to figure out how high the vehicle went. So for that, we go back to CrashMath. Now I'm going to add an equation, and I'm going to go over to my favorites. Now, when you find an equation that you like, say you want the formula right here, you can add the equation to your favorites, and that'll move it over to your favorites tab. And for this, I've already added some to my favorites. So what we're going to do is we are going to grab the distance traveled during the flight from takeoff to the maximum vertical height. So we need to know how far along this path he went before he hit his maximum height. So we're going to add that equation. And I'm going to call this max height distance. Now his velocity when he took off. So we have 117.509 miles an hour. And our angle for takeoff was 2.910 degrees. And our acceleration is going to be our constant, so 32 feet per second per second. We're going to hit solve. And at 46.792 feet along this path was where he reached his highest point. So 46.792. So we're going to go back to our 2D view. I'm going to grab my dimension. And And I'm going to find the point on his path that he was going 46.792 miles an hour. I'm going to snap to that point. This will be my dimension 6. I'm going to type in my length, and that's going to shorten that up to this point. Now, the next thing we need to know is the height, because right now it's giving a z value at takeoff. So its height at takeoff is 1.91. However, we know he went up from there, not down. So what we need to do is figure out his maximum height at this point. So we're going to go back to CrashMath, and we need to add an equation. So on this one, I'm going to go to my favorites, and we need maximum vertical height reached above the plane of takeoff. Add our equation. And we have our velocity, which should be in miles an hour, 117.509. Our angle of takeoff was 2.910 degrees. And gravity being our constant, we're going to solve. And he gained 1.189 feet of elevation. So I need to name this before I forget about it. And we'll call this max height. So it was 1.189 feet above takeoff. Let me get out my calculator because I can't do that one in my head. So we take 1.91 plus, I've already forgotten it already, 1.189. That gives us a height of 3.099 feet. So I'm going to input that value here, 3.099. And we are set. So now we have a point right here that is up in the air. So from here, what I'm going to do is I'm actually going to put a shadow car in here just to show his maximum height. So I'll copy this. And I will paste it in here. And I will snap this one to this point. I'll turn it to follow that trajectory. And we are set. So now what we need to do is take our motion path, and we need to align that path with our car that is now up here floating in space. So in our actions, what we need to do is we need to add a motion path node. It says it's going to remove the terrain conform, and that's okay. What I'm going to do is I'm just going to click somewhere out in here. It doesn't have to be precise. We're going to change that later, and we can hit escape when we're done. Now what I'm going to do is I'm going to turn my point snap on and snap it right there. So now what we have is our motion path now up in the air. So when we click play, and of course that doesn't look quite right. We've got a little bit of work to do here. So what I'm going to do is turn my shadow cars off. From here, I'm going to make some changes to my motion path. So these points here are curved, and then we get up in the air here, and then it turns into a line. So I'm going to turn all of these to a curve. And you notice some of these have terrain checked and some of them do not. Now, that's important when we make this conform to terrain. So over in this area, sometimes the motion path, I'll just zoom out here, sometimes our motion path dips below our surface. What we need to do is put that on our surface, but we don't want the whole thing on the surface. We only want this section and this section. So when I click on my motion path, I'm just going to make sure that the important areas, the parts that I want to terrain conform are checked, and the parts that I don't want to terrain conform are unchecked. So that in my actions, I'm going to conform that motion path to the terrain, and it will take the terrain parts and put those back onto the surface. Now, when I click play, and our vehicle lands right where it needs to. And we're looking pretty good here. I'll click stop. However, our velocities are wrong. So what I'm going to do is click on my motion path. I'm going to go back to CrashMath here, make sure I've got the right one, 117.509. And in my events, since this guy did not hit his brakes the whole time, my starting node, I'm going to enter 117.509 miles an hour. And in my ending node, I'm also going to enter 117.509 miles an hour. Now when I click play, off we go. Now what I'm going to do is turn off my dimensions. We're looking pretty good here. Last thing I need to do is click on my motion path. And I don't want that red line to be in there. So in my actions, I'm going to hide the motion path. And now, when I come down and I hit play, see if we can get underneath it. A little bit to the left. And we're set. So now what we have to do is we have to export this. Now CrashMath, this is going to be pretty simple. We have our three equations. We have our speed at takeoff, we have our max height distance, and we have our maximum height. What we do is we go to our print preview. I'll drag that window over. And we have our collision dynamics report along with our equations on 3 pages. That looks good. What I'll do is I will print this as a PDF and I'll include that in my case packet. Next thing that I'm going to do is I'm going to take my animation and I'm going to view the report on this just so that I have the proof that we're not just making this up and that we do have the ability to back this up with a calculator if we need to. So in my report, since I have animation in here, I'm going to click on my animation report. And this is where we would put in our report settings, our case name, organization, case ID, and investigator. And we are set to export it. Now, something else in our animation report is that we can export our time distance data as a CSV if you did want to do that. Or if you did want to export it as a PDF, we do have the ability to input different times. So at 0.40 seconds, the vehicle is at these X, Y, and Z coordinates, and it's telling us what the yaw and the speed are. So if you have a question about at what time did things happen, you can definitely back that up with a calculator on the stand and prove that this animation is forensically sound.